So we have permutations, one of the most practical topics in additional mathematics. So let's quickly look at these four different questions. So in how many ways can four white sticks and three black sticks be arranged in a straight line if there are no restrictions? So if you have no restrictions, and then you have 7 sticks, this is how you can arrange them. So just think of these 7 slots, 1 2 3 4 5 6 7, because we have 7 sticks. Remember 3 plus 4 is 7. So since we have 7 sticks to arrange and we have 7 slots where to put them, it means the first seat can be occupied in 7 ways, because I can put this one, or I can put this, or I can put this. In other words, any of the 7 sticks can take up the first slot. So that means we have 7 ways of assigning a slot to these 7 sticks on the first seat. By the way, this is true for any of these seats. So now once this one has been occupied, you can put a multiplication sign like that. To find the number of ways of assigning a stick to the second slot, just count how many sticks you have. So any of these 6 remaining sticks can take this one up. So in other words, we can assign any of the 6 sticks to be in this position. So let's say I've decided to put this one there. And then I have 5 more sticks remaining. So now any of these 5 sticks can take up this. In other words, we have 5 ways of assigning a stick to this chair or to this slot. So I'm sure by now you can see the pattern. So once I assign this one here, then I have 1 2 3 4 sticks remaining. So that means any of these 4 sticks can take up this slot. So I can put my 4 there and assign one of these remaining sticks. So once I do that, I have 3 more sticks remaining. So any of these 3 can take up this seat. That means we have 3 possible ways of putting a stick on the third chair like that. And then we have this seat. Any of these 2 here can take it up. So that means we have 2 ways of assigning a stick to this seat. So once we do that, we have 1 seat remaining and 1 stick remaining. So that means this can only be occupied by 1 stick, because we only have 1 stick remaining. So as you can see, this is the definition of a factorial. This is exactly what we call 7 factorial. And this is true in general. If you are arranging n objects without restrictions, then the number of ways of arranging these n objects will simply be n factorial. So your answer here will be 7 factorial. So it's just a matter of finding the product of all these numbers and then you write it down. So I'm not going to do that, because right now I just want to concentrate on the theory behind this as opposed to the actual calculations. So now let's move on to the second part. The second part is saying the 3 black sticks must be together. So if you want the 3 black sticks to be together, then this is what you do. So you can just separate the white sticks from the black sticks. Okay, so that means you technically have 1 2 3 4 5 sticks, because these guys must always be together, so you can treat them as one. So in other words, you have like 5 sticks to arrange without restrictions. Remember, this bundle can be here, it can be there, it can be there, it can be there, but whatever you do, they must always be together as one, like this. So in short, you have 1, 2, 3, 4, 5 ways of arranging this. Remember what we said on part A. If you have n objects to arrange in without restrictions, then you can arrange them in n factorial ways. So since we have 1, 2, 3, 4, 5 objects to arrange, we can arrange these 5 objects in 5 factorial ways. So now once you do this, remember, these 3 can also permute. In other words, they can also be rearranged. You can either put them in this order, or this one can take the middle position, or this one can take the middle position, or this one can take the last position. So it's not like these 3 are restricted to be in this order. So now what you do here is you multiply this 5 by the number of ways of arranging these 3 sticks. Remember, to arrange 3 sticks without restrictions, you can just say 3 factorial since you have 3 sticks. The point here is these 3 are not supposed to be in any order. You can put them in whatever order you want, provided they are still together. So this should be your answer every time they ask you to arrange n objects in such a way that m of those objects are supposed to be together. This is your answer. Then let's look at a situation where no 2 black sticks must be together. So if no 2 black sticks must be together, then what you do is you use what we call the gap method. So there is this other method people normally use. They'll just say in such a case, you just find the total number of arrangements, which is 7 factorial, and then you subtract a case where the 2 black sticks are together. So this will be like so when these 2 are together, this will be 1, 2, 3, 4, 1, 2, 3, 4, 5, and then you treat these as 1, and then after that you subtract. So this is not correct, in that it's possible that these guys may all be together. So it means you haven't subtracted this part here, which will not make it correct. Remember, when all the 3 black sticks are together, it means 2 of them are somehow together. Not even somehow. So this is what you do when you have a situation like this. So you just arrange the white sticks first. Remember, you have no problem with white sticks. You can arrange them in any order. So you can say 1 white stick here, 1 white stick there, 1 white stick there, and 1 white stick there. So let's do that. So you arrange them like that. So now, in how many ways can you do this? Remember, to arrange n objects in without restrictions, you can just say n factorial. So you can arrange these 4 sticks in 4 factorial ways. And then now you have gaps. You have 1, 2, 3, 4, 5 gaps. So if you have 2 sticks, then you expect to have 3 gaps. 1, 2, 3. If you have 3 sticks, you expect to have 4 gaps. 1, 2, 3, 4. If you have 4 sticks, you expect 5 gaps, because this space here, or this gap, it's not really a gap, but we call it that anyway. So this gap and this gap is also considered. So you can't just say 1, 2, 3, because you can put a stick there, you can put a stick there, you can put a stick there, and so on. So now, once you arrange the white sticks, you can now arrange the remaining 3 sticks. So now, in how many ways can you arrange this? Remember, you have 1, 2, 3, 4, 5 gaps. So this one can take up any of the 5 gaps here. It can either take this gap, or this gap, or this gap, or this gap, or this gap. So you can arrange this stick in 5 different ways. Let's say I decide to put it there. In how many ways can I do that? 5 times. And then I'm now remaining with 2 sticks, and then I have 4 gaps remaining. And then to arrange this, since I have 4 gaps, this stick can take up any of these 4 gaps. I can either put it here, or put it here, or put it there, or put it there. In other words, I can arrange this stick in 4 different ways. So I can just put it there and say I have 4 sticks. And then I'm remaining with 1 stick. In how many ways can I arrange this? I have 1, 2, 3. So I can arrange this stick in 3 different ways. And then this should be your answer. So it's just a matter of punching this on your calculator. Of course, you have to write this in expanded mode, and then, or you can just punch it as it is and get your answer. So this is how you solve problems like this. In other words, this is like arranging three sticks given 7 slots. So you can also write this as 4 factorial multiplied by, we have 5 gaps, 1, 2, 3, 4, 5. So you can say 5 permutation, and then you have 3 sticks to arrange. This is just an alternative. So if you understand this, then well and good. If you don't, you can use this simplified version. This is exactly the same as this. Since the permutation, 5 permutation 3 is defined as 5 factorial over 5 minus 3 factorial, which is 5 times 4 times 3 times 2 times 1 over 5 minus 3 is 2, so you have 2 factorial in the denominator, which is 2 times 1. Then when you cancel these out, you remain with 5 times 4 times 3. So this is your answer. If you want, you can use this. And you're done. And then let's look at the last case. The last case is saying the 3 black sticks must not be together. Okay, so the 3 black sticks must not be together. So in this case, this is where you can apply the method where you find the number of ways where the total number of ways, which is 7 factorial, and then you can subtract all the cases where the black sticks are together. The 3 black sticks are together. Remember, when the 2 sticks are together, this is not considered as the 3 black sticks being together. So with this one, you can just say, since you have 7 sticks to arrange, you can just say 7 factorial ways, which is the total number of ways, and then you remove all the cases where all the 3 sticks are together. So if you have 3 sticks together, then to find the number of arrangements, remember we found this on part B, where we said you can just treat these 3 as one bundle, and then you can say you have 1, 2, 3, 4, 5 sticks to arrange. So you have 5 factorial ways multiplied by 1, 2, 3. Remember, these 3 can also permute 3 factorial. So this is your answer for a situation like this, since we are talking about all the 3 black sticks. If the case was talking about 2 black sticks, you can't use this, because in this case, it means you have to subtract from the total ways the number of ways in which the 2 balls are together. I mean the 2 sticks are together. So 2 sticks together. And then remember, this is not the only case where 2 sticks are together. You can also subtract a case where all the 3 sticks are together, Because once you find this, it doesn't mean you have also found the number of ways in which all the three sticks are together. This one will only give you a situation where these two are together like this, or together like that, or together like this. It won't give you a case where they are all together. So in a case like that, it's better to use the method we have just used. So this is it for tonight.